Uh, Today we have chosen this famous title where every kid also is interested uh, the topic of time dilation and twin paradox. Here, for us, it will not be isolated trick of relativity. We will start from the root, what is meant by time itself, how Einstein's relativity forced us to change that idea, and then how time dilation and this twin story grow naturally, yeah, out of uh, this framework. See, in Newton physics and in everyday life, time is uh, absolute in a way. Uh, eh, we imagine that it flows uh, same for everyone, for independent of who is who. I mean, if somebody is moving or somebody is at rest. See, this is the pain point. Now, around 1900, tension appeared. See, Maxwell's equation suggested that the small c in vacuum has a fixed value. Mm. Now, uh, this Michelson-Morley experiment also failed to detect any preferred ether frame in which light would behave differently. So that means indeed the small c is constant. Therefore, Einstein asked this sharp question: can we keep the idea that laws of physics are same in all inertial frames and also accept that the speed of light is the same for all observers? To make both statements true, something deep must change, something must to we must give away, and that is this old idea of time. This in these slides, I'm just trying to show these intuitions that many cultures even imagined that time might be something beyond. In Indian mythology, for example, there were stories when a person travels to another uh, loka, which higher realm or some different realm, spends there sometimes which is shorter time for that person, feels like very small amount, but on returning to the earth he finds that many years have passed and their relatives have grown old. See, these are not scientific theories, but they show deep intuition in those days. And the idea elsewhere, time must be different. I mean, it can be passing differently. The two different paths to the universe might lead to different amounts of aging, so forth and so on. These are intuitive. But here, the things that we note here is spatial relativity gives a precise and testable version of these intuition. See in this slide, mhm, Einstein is reminding us that our usual sense of time and space is tied to how we think. Now, there are several implications to this code. We will not go into the deeper code, but we will stick to the simpler implications. Relativity forces us to see that the structure of time and space is not just a background stage but part of the physical law itself that we have seen. So, this simpler implication says, according to Einstein, one has to be ready to update these modes of thinkings if experiments and theory demand it. That's the simple. This line also captures something profound. Our everyday distinction between past, present, future turns out not to be as absolute as we feel it is. This was also certain cultures hinted at. In relativity, what is simultaneous for one observer need not to be simultaneous for another. In one of our videos, we have discussed this simultaneity to this speed of light thing. Once we accept that, our picture of time becomes much more flexible and subtle than this old Newtonian one. And these are the quotes that we are quoting because this debate later on uh, started, which we have covered the root of this debate later in this talk. See, now in the Newtonian view, there is a single universal time. All clocks are in principle trying to read the same cosmic time. Simultaneity is absolute. Everyone can agree on what happens at the same time. Whereas in Einstein's special relativity, the speed c is same. See, for him, nothing else is absolute, but this small c, it is same and it is same in all inertial frame. Therefore, the laws of physics take the same form in all such frames. The consequence is that observer moving relative to each other cannot share single universal time. See, and this we will gradually see in this talk. Time becomes relative. It is linked to the state of motion of the observer, first thing. And this time dilation and twin paradox are not extra mysterious sitting on the top of this theory. These are direct reflections, direct, we will see, of this new view of time. Now, before we start, we will first look at this original paper, uh, Einstein's 1905 paper on the electrodynamics of moving bodies. As we said, he took C to be constant and he redefined simultaneity using the light signals and showed that the moving clock must run slow relative to the given inertial frame. Therefore, the modern time dilation that we usually use is delta t is equal to gamma delta tau was already implicit in his work. And the famous twin paradox, which is a story which came later, as a way to kind of dramatize this whole stage and explore this consequence of relativity of the time. See, one of the Einstein's central postulate, we are just reminding of this 1905 paper, he stated like this: the speed of light in vacuum is same for all inertial observers, regardless of the motion and of the source of the observer. This is the starting point. Once you insist on this, and you also insist that the laws look the same, see, in all inertial frames, which is very natural. then you are almost forced into the new structure of space and time that we call spatial relativity. Now, instead of uh, looking at the formulas and memorizing uh, this simple model of light clock is what is all that you need. If you understand these, perhaps everything you will see clearly. See, on the left, we have a clock at rest, two mirrors, one top and one in bottom, and a light pulse bouncing between them. Each full up and down trip of the light pulse is, we can say, one tick of the clock. And on the right, we see same clock, but now moving horizontally at a speed v, relative to ground or relative to us. In its own raised frame, the light goes straight up and straight down. See, in our frame, now see, where the clock is moving sideways, the light follows diagonal path between the mirror. And that's it. If you see this diagonal path and if you ponder, uh, everything will follow. Now, imagine this simple device, light bouncing between two mirrors. One tick is full up and down, a trip as we have said. So in clock's own raised frame, light travels straight up, straight down. Therefore, the time per tick, delta T naught, what is it? It is 2L by C. Simple. Now watch the same clock from the frame where, where the whole device is moving at a speed v, as we said, from the ground, let us say. Now, while this light travels between the mirror, the clock itself has moved sideways. So, for this kind of moving frame, the light path is diagonal, and it will not be 2L, but the speed of light is c. So, a longer part at the same speed means more time between takes. So, in this frame, the moving clock runs slow. This is it. If you want, you can pause and give it a thought again. So the light clock is just a model, but the lesson or the implications that we are looking are far more deeper. That is, if the speed of light is same for all inertial observers, then the time intervals must depend on the state of motion. See, this is what it is. Okay, we can now express in a compact way that delta tau be the time between two events measured in the rest frame, and this is proper time. Okay. Let delta p be the time between those events measured by the observers in the ground frame, and the clock is moving at the speed v. So spatial relativity tells us this we will not be redoing. It is there. So delta t is equal to gamma delta tau, where gamma is 1 by 1 minus v square by c square. Okay, square root of this gamma is well known. Now this factor gamma is greater than or equal to 1. Correct? This means moving clocks ticks more slowly. What does that? Than the identical clocks at the rest uh, in the same frame. Okay. So this is now not limited to mechanical clocks. This is a further research, but every physical process such as decays, oscillations, even biological aging is affected in the same way. Here, there is a scope for further research. But nevertheless, it's true. Now let us look at uh, this work of Einstein, 1905. Uh, What are the ingredients? The ingredient is the relativity of simultaneity and time dilation for moving clocks. Therefore, in 1911, after perhaps 6 years, Paul Langevin took these ideas and presented a vivid story at certain, perhaps, conference. Fast traveler who leaves the earth spends a long time moving at high speed and returns younger than someone who stayed on the earth. See, similar mythological beliefs. This is essentially the twin paradox picture, built solidly on Einstein's foundation, but shaped over time by later discussions and debates and so forth. It's a way to explore how far we are willing to trust this new relative view of time. This is how certain theories uh, takes shape and solidify. Let's state this twin story very clearly. There is a thought experiment. One twin stays on Earth, the other twin travels in a high-speed spaceship and later returns to the Earth. So, using time dilation from Earth's frame, the moving twin clock runs slow, so the traveling twin should age less. There is apparent paradox now. See, what is that? Could the traveling twin claim the opposite? Because this is relative. Huh? From their viewpoint, isn't the earth that is moving? True, yes. So who is really younger when they meet again? This was the paradox. To answer this properly now, we have to go slightly deeper, slightly, into something called world lines in space-time. And there is a role of acceleration. As I said, if you in the light clock thing, there was a bent curve. There I said the same thing here is applicable. If you see, this is a simple space diagram. Vertical axis is ct, time multiplied by the speed of light, and horizontal is simple space x. The Earth twin stays essentially at some position on Earth, so their world line is uh, should be vertical, is going nowhere. Right? So time passes, but position does not change. That simple, straight line. Now, traveling earthward line looks different, just like our light clock when it was traveling. It was also uh, so bent. So they start from same event, move from Earth at high speed, turn around, and then come back to meet the Earth twin again. So their world line goes out diagonally as shown, bends at the turnaround and comebacks. So both twins share the same start and end points in the space-time. But see, they follow different paths between them. One is vertical and one is bent and and changing the frame. Yeah, it changes the frame. It was going that way and then turns around. So now we can resolve the paradox at its root. In space-time, each twin follows different world. Now between two events, there is a departure, there is a reunion. The key point is Earth twin remains to a very good approximation in one inertial frame throughout, right? So therefore, its world line is straight in space-time. Traveling twin does not go out, come back. So therefore, there is the acceleration. See, this turn around, yeah, this turn around makes whole mm, point here. So he must accelerate. Turn around means change, and change is acceleration. So he changes frame and must. So therefore, their word line is bent. The proper time along the word line, therefore, the time clock actually measures along that path. Huh? So it depends on the shape of that word line in space time. See, just like that clock. So in spatial relativity, between the same two events, straight word line, pure inertial motion, maximize the property, just like the clock picture. Now straight clock on the left. Okay. So any path that includes acceleration and changes of velocity gives less proper time. You see, the same thing of that because the earth twin who follows the straighter path ends up older. The traveling twin who accelerates and because its world lines are bent, it ends up young. So now there is no contradiction. The situation itself is not symmetric. So the simple thing you are moving and not I argument does not apply in the same way to the both of the twins because of this acceleration thing. So it solved this paradox. Yeah, acceleration. Now time dilation is not just a thought experiment about something imaginary, imaginary clocks, ideal twins. The effects are real in physics. See, fast moving muons created in the rays, cosmic rays, live longer than muons at rest, exactly as time dilation predicts. High speed particles in accelerators have extended lifetimes in lab frame. And precise even the atomic clocks, which are on airplane, which are moving, or in a satellite, which are comparatively higher speed, show measurable time difference compared to clocks on the ground. And in your everyday technology, we have talked about GPS satellites. They must correct uh, these effects, relativistic effect. Without those correction, there will be a positioning error, and as we know that it will grow in kilometers. So underneath all this example, uh, the same root idea, time and space are intertwined, and the speed of light is same in all inertia. Okay, so time dilation and twin paradox are not tricks of mathematics. They are natural consequences of starting from a new, deeper point. Trusting the speed of light and the form of physical laws, they, you know, they are the realities here, not uh, our old intuition of time. See, what you see exactly, the phenomenon happening is reality and not the time. So at the root, Einstein asked, can we accept that different observers might carry different times with them? And there is no single universal clock. The answer lay to the world, different world, where different observers genuinely have different times. And the path you take through space-time literally shapes how much you age. The reality. From that root, many branches have grown. Spatial and general relativity. General relativity, uh, in a way, is woven with this gravity, which has again time inputs. Therefore, and our modern picture of universe in cosmology, high energy physics, all these things, where you need such corrections, in fact, from this relativity principle. Okay, so after this discussion of time dilation and twin story, if it feels like a paradox and more like a natural result of a new way of thinking about the time, then the root idea of relativity has done its work. Thank you.